Welcome to this tutorial on PowerShell and Docker, where you'll learn how to manage Docker containers using PowerShell commands. Docker containers have revolutionized how we deploy and run applications, and PowerShell provides a powerful interface to interact with them. Throughout this tutorial, you'll discover the essential commands and techniques needed to effectively manage containers in your development and production environments. Containers are lightweight, isolated environments that package applications along with their dependencies. Think of them as self-contained units that run consistently across different computing environments. They are lightweight because they share the host operating system's kernel, making them much faster and more efficient than traditional virtual machines. Containers are also highly portable, meaning you can develop an application on your local machine and deploy it to any server or cloud platform without worrying about compatibility issues. PowerShell is an excellent choice for managing Docker containers, especially in Windows environments. It offers native Windows integration, allowing you to seamlessly combine Docker commands with other system administration tasks. PowerShell's powerful scripting capabilities enable you to automate complex workflows and create reusable scripts. Unlike traditional command line tools, PowerShell works with objects rather than plain text, giving you more control over how you process and manipulate data. Additionally, PowerShell is cross-platform, meaning the skills you learn here apply to Windows, Linux, and Mac OS systems. Before you start managing containers, you need to verify that Docker is properly installed and running on your system. The command docker -- version displays the installed Docker version. The command docker ps lists all currently running containers and confirms that the Docker daemon is active. To test that everything is working correctly, run docker run hello-world, which pulls a test image and runs a simple container. If you see a success message, your Docker installation is ready to use. Let's run your first container using a practical example. The command docker run -d-p80:80 -name web server engine x accomplishes several things at once. The -d flag runs the container in detached mode, meaning it runs in the background. The -p80:80 option maps port 80 on your host machine to port 80 inside the container, making the web server accessible. The --name web server assigns a friendly name to your container for easier management. Finally, Nginx is the image name, which Docker will automatically download if it's not already on your system. After running this command, use docker ps to verify that your container is running successfully. Docker provides several ways to list containers depending on what information you need. The basic command docker ps shows only containers that are currently running, displaying information like container ID, image name, status, and ports. To see all containers including stopped ones, use docker ps-a if you need formatted output that's easier to read. Docker ps-- format table presents the information in a clean tabular format. For automation scripts where you only need container IDs, docker ps-q returns just the ID values without any additional information. Managing the lifecycle of containers is a fundamental skill. The docker stop command gracefully stops a running container by sending a termination signal and allowing it to shut down properly. If you have a stopped container, docker start brings it back to life without creating a new instance, preserving any data or configuration changes. The docker restart command is useful when you need to apply configuration changes or troubleshoot issues, as it stops and immediately restarts the container. These commands use the container name or ID that you specified when creating the container. Container logs are essential for monitoring application, behavior, and troubleshooting issues. The docker logs command followed by the container name displays all output that the containerized application has written to standard output and standard error. If you want to monitor logs in real time as they're generated, add the -f flag, which stands for follow. This is particularly useful when testing or debugging applications. When dealing with containers that have been running for a long time and have extensive logs, Use the dash tail option, followed by a number to show only the most recent log entries. For example, dash tail 50 displays just the last 50 lines. Sometimes you need to interact with a running container or execute commands inside it. The docker exec command allows you to do this without stopping the container. Using docker exec -it followed by the container name and bash opens an interactive bash shell inside the container, where -i keeps standard input open and -t allocates a pseudo terminal. This gives you full access to explore the container's file system and run commands as if you were logged directly into that environment. If you only need to run a single command, you can specify it directly, like docker exec webserver ls/usr/share/nginx. You can even execute commands as a specific user by adding the -u flag followed by the username. Proper cleanup is important to prevent your system from accumulating unused containers. The docker rm command removes a container, but it only works on stopped containers. If you need to remove a container that's still running, add the -f flag to force removal, though it's generally better to stop the container first. Over time, you may accumulate many stopped containers taking up disk space. The docker container prune command is a convenient way to remove all stopped containers at once. Docker will ask for confirmation before proceeding, helping you avoid accidentally deleting containers you might still need. Regular cleanup helps maintain a tidy Docker environment and frees up system resources.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.